Advanced topics in Python. To be honest, friends, I had a difficult time choosing which two topics to cover in this nugget. There are so many other ones. Regular expressions is a topic that comes to my mind that bear time. However, because we can cover only so much in this Introduction to Programming with Python series, I've settled on two function-related advanced topics that can really make your Python programs more flexible, dynamic, and better performing. The first of those is the generator function. As we're going to learn, a generator function is a kind of resumable function that instead of running through an iterable just all at once and returning a single object, we can actually stop and resume. In other words, save state in a function's execution. Generators are pretty cool. The second advanced topic we're going to look at in this nugget is the decorator. Decorators are functions that you can use to wrap other functions in. Now, I know that sounds pretty esoteric. Actually, it is. Decorators tend to be one of those advanced Python topics that scares off a lot of would-be Pythonistas. I'm going to take things slow and easy, though. Let's get started. As previously stated, a generator is a resumable function. Therefore, a generator function is going to return results one at a time instead of just giving you the function result as a whole. Now, generator functions are used almost exclusively in looping constructs. For instance, the for loop. Now, why would you care about a resumable function or a generator? What's the purpose? The main reason why Python programmers like using generator objects for their for loops or their iterations is that you can save memory. Instead of running a straight-ahead iteration, which brings back all objects in a particular range, let's say, or list, you know how iterables work, we can conserve memory by using the yield statement and suspend and resume the state of that function. So in other words, we can go through an iterable sequence to a certain point, yield that result, come back later, and pick up where we left off. Isn't that great? Now, generators work with functions as well as expressions. We're going to do a little mini review on list comprehensions. You'll remember what list comps are. List comps give us a list from an iterable sequence using for. Generator expressions are pretty much the same things as list comps, but instead of spitting back an entire list, which again can increase your memory footprint of your application, as well as consume unnecessary CPU cycles, with a generator expression, also called a genexp, we can return results on demand instead of, as I said, a full list. To sum up, generators are good at optimizing performance of your program and minimizing memory footprint for those iterable sequences. Let's now have a look at a generator function. We'll look at the syntax. Now, if it weren't for this yield keyword, this gen square function, which is a function that simply takes a range as its iterable and comes back with the square or the power of 2 of that input parameter or argument. If it weren't for the yield, then this would just be a standard iterator, wouldn't it? Remember, an iterable is any data object that can be iterated through or cycled through one member at a time. You'll recall that strings are iterables, lists, dictionaries, tuples, and also some built-in functions like range are iterables. So the way gen square works is we have a single argument that comes in that provides the topmost element in our range. We're going to use for to cycle through one at a time all the elements or members in that range up to n. And because we're yielding a generator rather than just a straight ahead data object, we're going to invoke the yield statement. So therefore we could then assign gen square 6 to the name A, and A is going to be not a list, not a tuple, it's going to be a generator object. And I'll show you that in the demo in just a moment. Thing that's crucial to understand is that when you're using generators, you can then manually invoke the next member of that iterable sequence. So in other words, if we do next A, it's going to give us the very first value of for I in range 6, which would be 0. So 0 to the second power is 0. I'm telling you that the first time you invoke the next function passing in A, you're going to get 0 as your result. And then if you wanted the next member, you would just do another next A all the way until you reach an iteration error. Eventually, once you reach the top of your range, you're going to get a traceback. And in order to handle this in your code so that the program doesn't abort, you would simply run try and except and catch that error that you get when you finish. It's called the stop iteration message. Now this next function is important just from an architectural standpoint, because if we were not using yield and therefore we were just doing a straight iteration instead of a generator function, next is automatically invoked when you run the function. Yield simply gives us as the programmer flexibility and control stepwise over the processing of that iteration by means of, as I said, the next function. Now let's get into the interpreter and I'll show you how this works in Technicolor. Alrighty then, here we are in idle, and I'm going to start off pretty much duplicating what you saw on the whiteboard. We're going to define a function called GenSQ that takes one argument, n, and we're going to run our iteration for I in range n. Here comes the generator keyword, yield, and in this case, I to the second power. Now, normally in a function that's just going to do this in a non-resumable fashion, we wouldn't use yield, we would use, do you know, the return statement to return a value out of a function. A little bit of review from earlier in the course. So let's hit enter twice to get back to our Python prompt, and now I'm going to set the value of arbitrary name called a to a run of the GenSquare function, and I'll pass in 4 as my argument. Now if I just echo back a, you notice that it comes back as a generator object. Same thing if we run type A. Now you're wondering, okay, well how can we start to pull data from this function? As I said, we can do this one element at a time by using the next function. So if we're passing in 4, remember, we're starting our range with 0 and working our way up. Eventually, when we reach the top of the list and go beyond the range, we get a traceback, and the error that we're looking to catch here is stop iteration. So I think that pretty well shows you how generator functions work. Pretty nice stuff. Just by way of contrast, let me create just a standard iteration function. We're going to call this one ITSQ. IT square for iterator square. Again, it's going to take one argument. We'll do things a little different here. We need to catch our result. So what we'll do is create an empty list and then simply append to that list the results of a for loop. So we'll do